Hi everyone, welcome to another session of Docker series. And in today's session, we are going to talk about the Docker volumes. All right. So before we start with the Docker volumes, I would like to specify the problem statement. Not problem statement. I would like to highlight like why do we need volumes. So basically, whatever information we are keeping in our container, let's say our artifacts or reports or binaries or whatever is generated inside containers. So like the moment we stop the container, or maybe like we will kill them or remove them, then those information will be lost. So with the help of Docker volume, we are talking about the persistence storage about this. All right. So this is our problem statement, which I have narrated few minutes back, and what we are going to do in today's demonstration. So these three things will be I'll be showing you how to create volumes by using Docker file directly and all those. Apart from this, like there are two buzzwords, bind mount and Docker volume. So we'll be looking into these as well. All right, so let's get started. So with this volume, so basically this is an instruction which we can pass in our Docker file. So it's only defined like where like which directory will be considered as a volume. Okay, so I'll be demonstrating this as well. That is one thing. Apart from this, there are two ways of storing like wherein like you can persistently store the information or secure it, so it doesn't matter whether the container exists or it is in stop status. You can get the information and your data would remain safe. So one is bind mount, the other one is Docker volume. Now, we'll take a single liner definition wherein like you will get to know like what is the difference between these two. So Docker volume use a spatial storage directory within the Docker directory tree on the host machine. So this will store the information in storage directory itself. So Docker basically, if you have a look at the structure, they are nothing but are read or write layers only. So the moment we stop our container or kill them, that read write layer is not able to extract that information. That's why we need some storage directory wherein like we can segregate that data. So that is one thing. Now with bind mount, it's a file system. So you must have heard about mounting in Linux. So in same way, bind mount also work. It's mount a file or directory within another directory. All right. So this is just a one liner so that you can discriminate. Now, use cases. Which one to use in which scenario? So basically, if you want your storage or persisting layer uh, that is fully managed by Docker only, then Docker volumes would be the right choice. But let's say if you want to expose your storage system other than Docker as well, then bind mount would be the good candidate for that use case. All right. So let's get on to the demo part. So Docker should be up and running here. I mean, that is the prerequisite for this. So we'll check Docker images. Nothing is there. So what I'll do is we have one Docker file. Let me remove it. So this one is the old Docker file, and let's create another one. And let's on the insert mode. So in this one, I'll just demonstrating how we can uh, specify volume in our Docker file. So we just wanted to pull one CentOS image, and in this particular Docker file we will be giving volume as temp. So under temp directory we want to store our volume. Okay, so let me just quickly save this and let's build a file. So docker build -t my CentOS. Okay, so my CentOS image we have given, and we'll do dot and let's build this. So this will pull that image, and since we have provided volume as well, so this will cover our first demo part, like how we can create volume using Docker file itself. So this is done. Docker images. So you can see one image is there. Now let me quickly create a container. So we'll use docker run -it. So we are using it in interactive mode only, and we will be passing this one -v. So -v is for volume, and the name of our volume. So volume from Docker file. This is a long name, but let it be like this, and colon followed by the directory where we want to mount that, the same one which we provided in our file. Alright, and then followed by the image name. So let's run it, and the moment we run it we will get into the container shell itself. Alright, so if I do ls here, and if I do ls in /tmp, so this directory is there, nothing is there as if now. So what I'll do is, let me create one thing we can create. Alright, this is just a text, so I want to create something /tmp/ we can give docker.txt. So if I do cat and followed by this one, so you can see we have created. Alright, so right now this container is running. Okay, so we'll exit. So we are now out of container, and now we'll see docker ps. Docker ps, first of all we'll check. So since this is in exited mode, so -a will give us that. Alright, so this is exited 14 seconds ago, and now if we do docker volume ls, so you will see volume from Docker file is there. Now let me copy this, and if we do docker volume so we are inspecting the volume. So docker volume inspect volume name, and if you go there you will find a mount point. Okay, so now if I copy this and let's cd into this, And if I do ls, see, you will get to see the file which we have created in the container. It is available here because of this mounting itself, like with the help of Docker volumes itself. Let me quickly cat it so that we can check the information is relevant there or not, right? So that is one thing. One more thing would like to show you. Let's say if I create some new file here under this, if I do ls, you will get to see that two files are now. So this was there in container, this is just now I have created. Now if we go back again and let me just do let's recreate the container again with the same image, with the same volume itself. And if I do ls and no, not ls, if we do ls/tmp, so you will get to see the file which we have created from the host machine itself, like from the Vagrant VM itself. So with the help of volume, you can use this. Now I'll show you one more thing with this. Like let me kill our container. So docker ps hyphen a. Alright, so two containers are there, both are same, so we'll kill them one by one. So docker rm container id, docker rm followed by the next one. Okay, if I do docker ps hyphen a, nothing is there. Now still we can go to this directory and access the same. So again, like when we like kill our container or terminate them, still this data set is accessible. If I do ls, see, these two files are there. In fact, let me remove new file. Alright, so this is there. Now let me exit from here as well. Not exit, we'll do cd data. Alright, now what we can do is, with the help of docker volume ls, we can see how many volumes are there. So this is the first one which we have created. Now we'll create another one. So docker volume create and the name of volume. So manual volume. So this is the volume which we have created manually. If we do docker ls, you can see we have two. And if we inspect this, let me show you that as well. Just looking for the inspect command and just changing the volume name. So see, this is again the path where this particular volume is bound locally. Alright, so now this one is fine. Let me create another container. Docker run -id -v and the name of our volume. So this one is manual volume and colon followed by. So we need to specify the path where exactly we want this to be mounted on the container itself. So let's say I am giving data. Okay, and we will be using which one we should use. So we'll use BusyBox. busybox. So docker run -it-v followed by volume and the image name. Okay, let me run it this. So it is saying that this image is not locally available. It will pull it from the Docker Hub, and right now we are here. So let me just do a simple ls, and we have this. So let me do ls/data. So this shows that this is there. Now if we do same echo from container, and if we just simply pass this just creating one file, test.txt, just for the sake of doing it. So if I do ls/data now, so it will show you there is one file called test.txt, and if we cat it, it will show us the status of this. Alright, so this is the second way. So what we did, we have created our volume manually, and runtime we will provide this to the busybox. So exit. And now we will be covering the third way, let's say without okay, before we do that, let me just show you that this one is still reflecting, and our docker, this one docker ps-a, that is already exited, so still we can able to access the data. So if I do ls, and if I do cat, so see, container is not there, but we are able to access it. Now cd, let's jump onto our third one. So this time what we are doing is we are simply running another container, docker run. Okay, I was forgot to tell you about this busybox. So again, this is a tiny image, in fact of 2 MB itself, which is having all the utility of your Linux machine. So it will behave as a Linux machine itself, but with lightweight. There is another version of there is another similar version of this type, which is Alpine, which we are going to use now. So again, -v. So we are now passing volume directly. So we can write dir direct volume colon, and followed by, let's say, opt. So this time we want to keep under opt. And one more thing I would like to show you. So if I use another colon, and if I use arrow, so what I'm doing is I want to use this volume as read only, so no one can update the data and all. I'll show you. So now we are using Alpine image. So Alpine is again a lighter image of 5 MB, and this is also the same like busybox. So busybox is kind of using some internal library which can be statically or dynamically binded with some library, whereas Alpine image is also similar to that, but busybox is smaller in size, 2 MB. Alpine is around 5 MB. Alright, so let me run this quickly. So again, system is saying that this image is not available on the local machine, so it will pull the same from our Docker machine. Alright, so we are right now in this root folder itself. So first of all, we'll check by doing ls/opt whether this directory exists or not. So it exists. Okay, And if I do simple ls, you will get to see everything is there with the like our Linux file system thing. All right, now if I do echo, just a minute, I'll just type my name itself and will try to send this as an output to opt/tm dot txt. So this should not allowed. So see, it is saying that you are using a read only, right? Because we have mentioned our volume as read only. No worries, we'll exit from here. All right, and we'll go again and we'll remove this option now, arrow. Okay, and if we go again and if we try to do echo, and if we do opt/tmp.txt, and if let's say if I enter, if we do ls/opt, so temp text is there, and if I copy, so this one is also there, right? Alright, so let's exit from here as well, and if I do docker volume ls, so now you can see the volume which we have used, direct volume is there, and if you want to inspect it, again same docker volume inspect, and if you can go inside this directory, you can reclaim the data. So see, this is how works here, right? All right, so that is one. Now I'll show you one more thing, docker ps-a. So all these container are in exited status, but still like we are able to extract their data. Okay, now let's say I want to use so we'll be using this volume now. Okay, name of our volume is -v, and we want to use Alpine image only for this, and we want to pass the container name as well. So hyphen name, and like say lpin cont. So I'm just using short name Alpine container, just so that we can get to know why we are using container, because name, because earlier we are directly using them, so they will exit the moment you exit from the terminal. Now I'll show you, like let's say if we create a container, so IT we want them to be in interactive mode, then volume we have already provided, and Alpine is the image, so this should be like we will be using this at the last. Alpine. Also, I don't want to, like I want to keep the container on. So for this, we may need to write this. So just a minute, I'm just writing one small script which will keep our container alive. All right. So what we are saying is like while true, and just go for sleep for 30 seconds if it is done. So this is just a way to like keep the container live only, otherwise it will be exited. So if it work correctly, then the container will be up. Let me just run it. Let's check whether it will. It's taking more than usual, but we'll see. Docker run -it -v volume also I have given. Okay, let me abort it because not sure what went wrong. We'll cover it in our next session. Alright, so these three use case we have covered. One thing I would like to show you is, like, with the help of container name, either we can pause it and all, but still you got the idea like how it works. Okay, so one more thing before we wind up. So Docker volume, if we do Docker volume ls, so it has created this one. No worries. So like, how do we clear all those stuff? So you can simply write Docker volume and prune is the option. And if we do Docker volume ls, okay, so it is saying that like it will only delete when okay, no worries. So we'll check. We'll go with Docker ps-a, and now I will, like, all of them are already in exited mode, but let me do this. So we'll do Docker remove followed by the name of container. So this one is the first one. Then you can remove them with the ID as well. So I'm just doing the cleanup part so that we can remove all the volumes as well. That is done. Now the last one. So if we do Docker ps-a, nothing is there, and now it should allow us to do that. No, this one is not working, not sure why. No worries, I will delete them manually. So what I can do is, you can use Docker volume rm, and this is done. Now you can delete the second one, Docker volume rm, Docker volume rm all. Alright, so everything is clean. There are images available which I will be cleaning after this one, but like, now you got the essence, like why we are using Docker volumes and how handy these can be. So this is what I have planned and prepared for this particular session. We should end up here only. I hope you like this video. Thanks for watching. Thank you.